Hello and good morning. Welcome back to Saturday Morning Coding. Today we are gonna try to finish this game. Um, and well, I'm telling first what's the current state of the game. So now you get a ball that starts randomly in the middle. Winning condition, ending condition, and you can move um, move the player. And now what we need to do is to create the computer player, and we need to have some sort of strategy. So let's get to the iPad to see what can we do. No, I forgot my- yeah. Uh, this is gonna be a lot of trial and error, but let's see. I have let's switch. Okay, so uh, so the idea is that uh, the computer player, which can move only vertically, can see the ball, can see the current position of the ball, and um, and it's moving towards the ball. So if the ball is above the current position, then it goes up. If the ball is below the current position, then it goes down. But we need to see, because it needs to be with a certain speed. That's the parameter that we will need to tweak, because it's possible with this strategy, if the computer player is too fast, it's possible to create a player that it's impossible to win against. So we don't want that for a game. So uh, the idea is that, yeah, every frame, every time that it updates the position, checks the current position of the ball, and moves towards that position with a certain speed. And of course, then we need to implement that we need to implement that if the ball hits, then it rebounds the same way than in the other player, of course. So that's the idea, that every frame the player, I don't know if you are used to this notation, but this means for every frame, it's a bit of mathematical notation, but you can skip it automatically. I mean, this is what I'm used to use, but it's absolutely relevant. So for every frame, take ball position, if y, bigger than paddle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, dot y, then we move up, no, sorry, if the paddle y, if the y is bigger, this means that if the y is bigger, this means that the ball is here. So we move down. If y is less than paddle dot y, then we move up, and if y, yeah, this y is the ball y, what I could have it's equal than paddle dot y, we don't move. So that's the idea. And then obviously in a game that would be totally fair, the speed would be the same as the player has. So but let's see about that, because we also have we also want that the player has actually some chances to win. So let's see. So far this is going to be the strategy, so let's implement this strategy. Back to the editor. So the first thing that we need to do is we have the player paddle, but obviously the player paddle we have the computer paddle still hasn't been created. It's still here, so we need to abstract it and create its own object. Right now it's only a static thing, so this is the first thing that we need to do. And we can create a new JavaScript file. And then we can do graphics. These are the left paddle graphics, which will disappear from here, and we will do like computer play paddle graphics. And these graphics that we created just for being able to check the looks at the beginning, this graphics file, now it's empty, so we can remove it. And we can start creating our own. So this in this left paddle, it's not left paddle anymore. We are gonna refactor it and call it computer paddle. And this is gonna be computer paddle graphics, and so on. And now in here we can call this computer paddle, computer paddle. Yes, and we need to include it here. We will see how can we combine all these files into one to create the game that is a single file, but that's after we have the game finished. So now we have abstracted this, and if we see here, it should still be. Oh, now we are not painting it, but we are not painting it because yeah, it's still called computer paddle. Still called the paddle there. So if now we reload, we should have exactly the same thing, but refactored. Okay. So now we start coding the behavior, encoding the behavior of the computer paddle. First, computer paddle update function of engine. And this is the one which will have the will be the core. So you see that in the player paddle, well, we can set the here we are checking that basically this is the core. So instead of if the engine is if the key is pressed, up or down key is pressed, then we need to do the same, but based on our internal decision, which is so we can basically copy this movement up and movement down, but obviously we cannot use the key pressed anymore, because now if we do this, if we do this, are we calling the update function? Yeah, we are not updating it, so now we need to update as well the computer paddle. And now both need to be at the same, moving at the same time. Which is, I mean, obviously still the computer doesn't have collisions, so that's the next thing before we implement the the computerized movement. I don't like to call it intelligent because it's not intelligent. It's not a AI movement or anything like that. But yeah, that first we need to code the collisions. Those are in the ball, so we consider that the collisions are this rebound. Yeah, this paddle collision. Yeah. It's just enough this paddle collision. Yeah. Let's see if this works, because we are playing here this plus. We may need to change this condition. But yeah, let's see, because it might be rebounding with the back of the paddle, but we basically call this function again, but instead of player paddle, computer paddle. Okay, there's obviously something that is wrong with these collisions, as I was the first thing. Yeah, obviously we don't need to load this graphics file anymore, so this can just go away. we're still not colliding with the ball. So we may need to let's refactor this, because I think that the problem is that we are not being able to, we are not going to be able to reuse this because of how this works. So let's see first. Let's check if this is being called appropriately. Okay, so if this dot x plus get width, no, we don't need to add the this dot x is, if this dot x is less or equal than paddle dot x, this means that because we collide with the it's not the center, it's the top left corner, so we don't need to add the width to this. So and this dot x is less than or equal paddle dot x minus this collision pixel threshold. Collision pixel threshold, then collision frame threshold 20. Okay. And this y is bigger or equal than paddle y. The ball is at the same height than the paddle, at least. And this dot y is less than or I mean the y should be let's see, I think that the y should be the same. Ball is not defined. I don't get this now. Ball is not defined. Mm. Okay. Funky. Okay, so this collision is still not working. If this that x less than or equal than minus parallel dot get high. So let's forget about the complicated condition. Let's forget about this now and see why it's not. Why it's not colliding. Rebounds from the back though. That's exactly my fear. Rebounds from the back. So yeah, really rebounds from the back. And the ball and this dot x is bigger or equal than parallel dot x plus collision pixel threshold. So the x is on this axis. So plus the parallel plus the collision threshold. So it needs to be bigger than this minus the collision threshold. I'm colliding with the back in both cases. So I'm colliding with the back in both cases. Yeah, these collisions need to be reworked, but yeah. Hey. These collisions need to be reworked. So the thing is, the collision pixel threshold should be much less. 1. These are gonna be reworked. This is, for some reason, these are not being like proper collisions, but let's concentrate now on the movement strategy for the computer. So if we go now to computer paddle, we need to have if I'm gonna call it move up function of the engine, because we will need to access the ball, and move down. So here is there, if we can do if this dot move up engine, if this dot move down engine. So we can see the basic idea here. So it's not like the key press anymore, but now it's an automatic decision that the computer makes. So const ball const engine dot sprites sprites engine dot sprites dot ball. Then the corner is on the top left. So if the corner is on the top left, then it's for moving up. The ball dot y ball if return false. So this is both. I mean, we could pass the ball here as some sort of, instead of the engine, as an optimization, but it's more flexible if we pass the engine. We can think about those later. about those optimizations when the game is actually something that is semi-finished. So if ball dot y is, so it's less than this dot y, we can have a threshold here, but let's see how this works. Return true. If it's bigger than this dot y plus this dot get height, then return true. Now we have a computer player that is almost impossible to win. And it's impossible to win, definitely. We need to add some randomization here, otherwise it's, and the collisions need to improve. Otherwise this game is impossible to win for the computer player and for the real human player. We could simulate better like human behavior by just adding like a there, that he has some sort of reaction time, or or because now as it is, it's impossible to win for the human player. The maximum that the human player can get is a perfect game where nobody misses ever. So we can add some randomization. Because at the end, I mean, obviously creating a perfect player is not what we want to do from the point of view of the fun that somebody can have on the game. So yeah. Let's see. We can give it. Yeah, this is gonna be fun and a lot of trial and error. So I mean, this is. We can check how to generate random. Yeah, that I was answering a phone message that yeah, that the yeah, I'm thinking if we had we can say, for example, something like if math.random is bigger than 0.5, return true. So this is an option, like some sort of small randomization. I mean, so the player is not perfect. Let's see how this works. And yeah, now it's still possible. Now it's the player reacts, but it's possible to win. Yeah, maybe this strategy combined with a bigger speed, it's already okay for the scope of this game. So instead of 2, we can make the computer paddle speed have a speed of 4, which is double the speed of the player. But only moves in the correct direction half of the time. Maybe 4 is too much. 4 is maybe too much because now it's becoming too good again. 3. Well, we can abstract this to a 0. This dot I mean, this is no example of good game design, or doesn't even try to be good game design. But we are trying to make something so it's playable and yeah, serves as an example of what the collisions need to be worked out. The collisions are not good at all between the paddle and the ball. Now it's still again too good, the computer. So now we have 2 parameters to modify that we can modify the speed and the probability of actually moving, which are the two. If we put the speed to 2, yeah, the collisions are really bad now. The more I play, the more I notice that those needed to be really worked out. Yeah, that should have collided, and it hasn't. So something that isn't properly coded there. And also we can introduce a probability that that it returns it falsely returns true. So the computer can make an error as well. Computer paddle error move p equals 0.2, for example. So if movement error move p, then this means that if this probability returns true when it shouldn't return true. So and same here. So there's a chance that even though the ball is above, the guy is going down or not moving when he should. The probability of that happening is very low, but it's still something that can happen. Because you don't want perfect players. I mean, the idea when you are creating a computer player, the idea is not creating a perfect player. The idea is creating a player that is fun to play against and provide some challenge. But it's not perfect, because if it's perfect and it's not possible to win at all, which is doable in many games, then the game stops being a game and it stops being fun, and then it sucks as a game. Maybe it's good as a exercise on artificial intelligence, but not as a game. I think that now we have a more or less okay player that you can still win against. That it's not so easy to win against, but it's not impossible to win. Let's test play again, and then we have to work out the collisions in a better way, because these collisions suck. These collisions are really bad. And then when we work out these collisions, there will be maybe we can use some sort of way to make the game progressively more difficult, like increasing the speed of the ball progressively or something. Yeah, basically that would be the game. And then obviously creating a fancier, like you lose screen or you win screen, and maybe a title screen, and then the game would be done. I mean, obviously this is an example. This doesn't aim to be like a masterpiece of game design, as I was saying, but yeah, the collisions here are the thing that is totally breaking the game right now. So let's think about those. I'm thinking, let's work out the collisions in the ball. So maybe we can get back to the iPad. I don't know if it can be seen or I need to. I'm not sure. Let's connect again. Okay. So the idea is for the right paddle, the player paddle, we have the paddle, and this point is the one that the engine stores. So and then the ball, which is also a smaller thing, but also with this. So we need to check, in the case of the right paddle, we need to check that ball dot x plus ball dot width is bigger or equal than paddle dot x, and at the same time we need to check that the y it's between these two, and ball dot y is bigger or equal, because ball dot y is this, so it's bigger or equal than paddle dot y and ball dot y is smaller or equal than paddle dot y plus paddle dot height. So these are the three conditions that it needs to come from for the player. And this is for the player, and the ball is coming this way. But for the other, for the computer, we have the opposite case. Where the ball comes in this direction, and we have this point and this point, and obviously this width and this height. So now, in the case of the computer player, so we need to check that ball dot x is is because we are coming in the negative. That's the thing as well, that the axis on the screen go like this: x positive, y positive. So ball X needs to be bigger or equal. No, needs to be smaller or equal than parallel dot x plus parallel dot width. And parallel dot x needs to be less or equal than parallel plus parallel dot width. And now we have to check the y, and ball dot y has to be bigger or equal than parallel dot y. So now we are talking about this. Parallel dot y and ball dot y has to be smaller or equal than parallel dot y plus parallel height. This would be the basic collision detection. So let's switch back to the code, and let's just implement this. Let's comment this and start our own collision detection. So this is the plier parallel. So we need to check that if this dot x plus this dot width is bigger or equal than parallel dot x. And this dot y is bigger or equal than parallel dot y. And this dot y is smaller or equal than parallel dot y plus parallel dot get height. Then we return true. So yeah, this, and now for the computer parallel collision we have same, except that this dot x has to be smaller or equal than parallel dot x plus parallel dot get width. so far we are not having we are not using the thresholds or anything. Let's see how this works out. Well, now the player is so bad. Now the player is so bad. I did something that the player became so bad. I don't know why the player became that bad right now. Okay. Ah. So this movement, if it's bigger than this, that means that it's 0.6. So it needs to be smaller than that. Or smaller, actually smaller and equal than that. For this to be a true probability and not the opposite. Yeah. Now I'm still colliding from the back. So this is the thing that so now how we don't want to collide from the back, so let's get back to the iPad. So this threshold is the amount that we collide from here. So this would be the threshold. So that means that the ball X should be smaller than this, but we need to incorporate another condition here for accommodating this threshold. So it should be smaller than this, but should be bigger or equal than parallel dot X plus parallel dot width minus threshold. So it should be bigger or equal than this. and and for the other player, for the human, it will be on this side. So this is threshold. So ball should be bigger than the x, but smaller ball dot x plus ball dot w should be smaller or equal than paddle dot x plus threshold. So this is the other condition that now we need to do to improve the collision. So this, I find it very useful that sometimes when it's you draw, you start to think a little bit about it, and because if you get stuck into trying to do it with your in your head, that's that you are gonna have a hard time. So let's try this again in the code. So now and this dot x plus this dot get width is smaller or equal than paddle dot x plus this dot collision pixel threshold, and this dot collision pixel threshold we are gonna put to 2 or something like that. So it's gonna be 2. It's gonna be configurable. And for this other condition, we have an ball dot x is bigger or equal than paddle dot x plus paddle dot get width minus this dot collision pixel threshold. No, this is not ball, this is this. And there's still some corner cases that we need to think about, for example, but we will do that in the next session. But yeah, what the thing is, let's get back to the iPad. The thing is, for example, what happens when you collide with this region or this region? It's never gonna collide with the back, but it still can collide with this region and this region, the ball. So that needs to be a special case. And we want, if this is the parallel, we want the ball to collide like this, but we want to do the collision with the other axis. So this is something that we will have to do, we'll need to care about in the next session. But yeah, drawing, the lesson is that drawing is important sometimes to understand the idea, and yeah. So let's see now how the collisions are working. Yeah. We are not colliding with the sides, and that's it. Much better now. We still need to do the collisions with the top and the bottom of the paddle. That can happen, but we are progressing. Yeah, and I think that this is gonna be it for today. My plan was to finish this today, but it's been not possible. So we still have two things to get that we need to care about. That it's that it's the collision with the top and the bottom, and the top and the bottom of the paddle, uh, and uh, and then I'll improving a little bit the computer player if we get some idea, but this is not the goal. This is not a course on artificial intelligence, so the goal is to make something that is fun to play and doesn't feel like impossible to win. I mean, right now it's a little bit maybe too easy, or who knows, but it has a little bit of randomness, so it's not that easy to predict how it's gonna work, or a perfect strategy to win. Yeah, and yeah, and then maybe a little bit work a little bit on the aesthetics, maybe having some background for the field or something that is not too distracting, but you know, something. And then obviously that you lost and you win screen need to have a little bit of aesthetics, and then the game will be finished. Yeah, we need to implement collisions with the top and the bottom of the paddle as well, which is something critical, because otherwise it feels like the ball is going through your paddle, and that shouldn't happen. So yeah, so this is the point where we are now. This as usual, this video is gonna be on YouTube, like the others, all the others from this project. This is gonna be used as some sort of introduction for the engine, and yeah, that's about it. Thanks for passing by, and see you. But maybe if I have the energy, maybe I create a rogue stream tomorrow as well about this, because I want to finish this as a way to because it's gonna be a tutorial, a video tutorial for the use of the library, so I don't want it to be like overtly long. Like, I want it to be so that it's available as well at some point, and that's it. I will post if you you can follow me on Twitter. I will leave the handle, and I always tell in Twitter when I'm gonna stream. If I am tomorrow or this evening maybe streaming, you will get to know, and just follow me on Twitter. Thank you very much. Okay, something else that I need to post in the chat, that this is the channel where the videos are, so you can check it out as well. And that's it. Now it truly is it. So see you, and see you maybe tomorrow, maybe this evening, or maybe next week. And thank you for coming. Bye.